Welcome to Learn with Roblox. In today's video, we're going to talk about angular relationships whenever we have two parallel lines and a line that cuts through them. So here I've drawn two parallel lines as marked with these arrows, and I've drawn this line that cuts through them, which is also called a transversal. So what are some angular relationships you need to know whenever you're dealing with situations like this? First, I'm going to draw these two angles. Let this be x, and let this be y. What you need to know is that x plus y equals 180 degrees. And why is that the case? Well, notice that x and y are along this straight line over here, and the sum of the angles along a straight line is always 180 degrees. So that means x plus y equals 180 degrees. And these are called supplementary angles. I also want to point out how there's many other places that you could draw supplementary angles as well. So for example, these two angles are supplementary, or those two angles are supplementary. So there's lots of places that you can find supplementary angles, and it's a good one you want to know to solve many problems. Here's another relationship that you want to know. I'm going to draw these two angles that are across from each other. These angles are called vertical angles. So I let this be x and let this be y. What's the relationship for vertical angles? Well, what you need to know is that whenever we have these vertical angles, they equal each other. So here, x equals y. In addition, I could also draw these two angles over here. Those are also vertical angles. So here, A would equal B. So these are another easy one that you can spot in many problems as well. And now I want to talk about these two angles over here. What can I say about these two angles if I let this one be x and let this one be y? Well, let's think about it. Let me draw this angle over here first. What do I know about this angle and that angle? Well, I know that they must be equal to each other. Why is that? Well, notice how they're drawn the exact same way. You have this line that comes down and then goes to the left, and then this same line comes down and goes to the left, and these lines are parallel. So you know that these angles over here are in the same situation, so they must be equal to each other. So if this is x, this angle must also equal x. But then what do we know about these angles over here? That's just the vertical angles. So therefore, I know that x is equal to y here because of vertical angles. So now I know that if I have this angle x up here, and have that these two lines are parallel, x must equal y. And this is something called alternate exterior angles. The reason it's called that is because first, these are called alternate because x is to the left of this line, and y is to the right of the line. And it's called exterior because you are outside of the parallel lines, not between them. And notice there's other places that I can draw alternate exterior angles. For example, these two are also alternate exterior angles, so they must be equal to each other. Another related one are these two angles, which are called alternate interior angles because they're on opposite sides of this line, but they're between the parallel lines, so it's called interior now. And what do we know about these alternate exterior angles, let this be x, let this be y as always, is that they equal each other. And notice I can also draw this version as well, where I have this angle and that angle. Those are also alternate interior angles as well. So let this be A and let this be B. A is equal to B. And a way that you can prove this pretty easily is by doing vertical angles again. So I know the angle A must equal this angle up here because it's the same situation. And then A has to equal B through vertical angles. So that's how you can prove that alternate interior angles are equal to each other whenever we have parallel lines and a line that cuts through them. And finally, here's one little trick you can use whenever you're in a pinch. Notice how all these big angles are equal to each other whenever you have a line and two parallel ones. That's a quick trick you can use. And in addition, all these small angles are also going to be equal to each other. So that's one final trick you can use whenever you're in a pinch or you're having some trouble. Now let's take a look at some problems dealing with angle relationships. In this first problem, we have that this angle is 125 degrees, and based on that, we need to find angles x, y, and z. The first thing I'm going to do is just realize that angle z is just equal to 125 degrees. How do I know that so fast? Well, notice that angle z and 125 degrees are just drawn the same way. You have this line that comes down and goes to the left. You have that same line that comes down and then goes to the left to form angle z. So angle z is drawn the same way as a 125 degree angle. So therefore, I can just write 125 degrees here. Now, how can I find angle x and y? Well, notice, angle x and 125 degrees are along a straight line. Therefore, they're supplementary and they equal 180. So I can write that 180 degrees is equal to 125 degrees plus x. And notice for y, I can do the same thing because angle y and 125 degrees are along a straight line. So they add up to 180. So I can also write 180 is equal to 125 degrees plus y. So to solve these, all you need to do is subtract 125 from both sides. So you'll have 180 minus 125. And if you do that, what you're going to do is, what you're going to find is that x and y are the same thing, and they're equal to 55 degrees. So that's it, we're done. Let me just replace this diagram with the correct degree measures. So x is 55 degrees, and y is also 55 degrees. And notice how x and y are the same because they're alternate exterior angles. So remember, these two angles over here are alternate exterior angles, and those are always the same whenever we have two parallel lines. So that's why this problem makes sense. Let's go to the next one. In this problem now, I have that this angle over here is 77 degrees, and based on that, I need to find angles x, y, and z again. So first, I'm going to know that angle z and 77 are along a straight line. Therefore, they're supplementary angles that add up to 180. So I can set up that 180 is just equal to 77 plus z. And then now I can just subtract 77 from both sides. And if I do that, I'm going to get that z is equal to 103 degrees. So I can write that now. So I'm going to say that this angle over here is 103 degrees. What can I do now? Well, notice that angle y over here and 103 degrees must be the same thing because they're drawn the same way. You have the line that comes down and goes to the right, and you have this line that comes down and then goes to the right in another parallel line. Therefore, 103 degrees and y are the same thing. So I know that this is 103 degrees. And finally, I know that x is 77 degrees. How do I know that? Where these are along a straight line. So 103 plus x equals 180 degrees. And that's the same thing as this situation up here. So just from that, I know that x must be 77 degrees. Another way that you could have come up with x is by realizing that 77 up here and this angle down there are alternate exterior angles, so they must be equal. So that's another way that you could realize that x is 77 degrees. That's it. In this problem, I need to solve for what x and y are equal to, and I need to find the value of each of the angles in this problem. To solve this problem, I'm first going to realize that these two angles over here are supplementary because they're along a straight line. That means that they add to 180 degrees. So if I add both of these together and set them equal to 180 degrees, I can maybe use that to solve for x. So let me do that. I'm going to say that 3x minus 6 plus x plus 2 is equal to 180 degrees. And then if I condense this, 3x plus x is just 4x, minus 6 plus 2 is just minus 4. So I'm just going to have 4x minus 4 is equal to 180 degrees. Just add 4 to both sides. And now I'll have 4x is just equal to 184 degrees. So just divide by 4 to solve for x. And 184 divided by 4 is equal to 46. So x is equal to 46. So now what I can do is I can find these two measurements here. So x plus 2, that's very easy. 46 plus 2 is just 48. And then to find what 3x minus 6 is equal to, I could plug in 46 into that equation and see what it is, but I could also do something easier. I know that these are supplementary angles, right? So all I know is that 180 minus 48 must get me whatever this angle is. So that's another easy way you can do that. And 180 minus 48 is equal to 132 degrees. So I can just erase all of this here. And I know that this is just 132 degrees. Now, what is angle y equal to? Well, notice that this angle over here and y down there are alternate exterior angles. Because of that, we know that they must be equal to each other. Therefore, y is equal to 48 degrees. So just like that, we found what x and y are equal to, and we found every angle in this problem, so we're done. In this problem, I need to solve for all the unknown angles, and I also need to solve for what a and b are equal to. To do this problem, I need to find some angle relationship that I can start with. Well, what I can realize is that 76 is equivalent to 17a minus 9. And how do I know that? Notice that they're drawn the same way. You have this line to the right that goes down to form that 76-degree angle, and you have a parallel line that goes to the right and then goes down along that same transversal line to form the 17a minus 9 angle. Therefore, these angles are the exact same because they've been drawn the exact same way. So I can set these equal to each other and solve for a. So I'm going to step down for a bit and set up this equation. 17a minus 9 equals 76 degrees. Just add 9 to both sides, and that'll get you 85. So 17a is equal to 85. And then just divide by 17. And then 85 divided by 17 is just 5. So a is just equal to 5. And I've solved for one variable. And also, I know what this whole 17a minus 9 is equal to. It's just 76 degrees. So that angle is done. And I can just write 76 degrees here now. Now, what can I do to solve for b in this equation? Well, notice that 76 degrees and this angle over here are along a straight line. So they're supplementary. They add up to 180 degrees. So I can set up a new equation where 76 plus all of this is equal to 180 degrees. And that will help me solve for b. So I'm just going to erase a for a moment. I'll rewrite it. And write 8b plus 16 plus 76. That has to be equal to 180 degrees. Well, first 16 plus 76 is equal to 92. And then you can subtract 92 from both sides. And if you do that, what you should find is that 8b is equal to 88. From there, just divide by 8. And 88 divided by 8 is just 11. So b is equal to 11. And then how can I find what this total angle is? What is 8b plus 16? Well, all you need to do is just do 180 minus 76 degrees, because these are supplementary angles. And if you do that, you'll find that this total angle is 104 degrees. So what I can do is I can just replace this whole thing with 104. And let me just write a and b again, because I said we needed to solve for those. So in this problem, we got that a was 5 and b was 8. And that's it. We're done with this problem. In this problem, I need to solve for what a and b are equal to and find the measure of each unknown angle. To do that, I need to find an angle relationship I can work with. So first, notice that 4a minus 17 and a plus 34 are alternate exterior angles. What do you know about alternate exterior angles? Well, they're equal to each other. So I can set up an equation where 4a minus 17 has to be equal to a plus 34. And I can solve this equation for a. To solve this, let's add 17 to both sides first. If you do that, 34 plus 17 is just 51. So 4a equals a plus 51. Then just subtract a from both sides. 4a minus a is just 3a. So I have 3a equals 51. Finally, just divide by 3 to solve for a. And 51 divided by 3 is just 17. Therefore, a is just equal to 17. Now, let's use that to solve for a plus 34 and 4a minus 17, so I can find those unknown angles. So first, a plus 34, to find that angle, just plug in a equals 17. So I can just rewrite that as 17 plus 34. And 17 plus 34 is just 51. So therefore, this angle down here is just equal to 51 degrees. And remember, this angle down here and that angle up there are the exact same due to alternate exterior angles. So I can write this whole thing as 51. And let me just write that a is equal to 17 since we needed to solve that. Now, how can I solve for b and what 9b plus 57 is equal to? Well, I know that 9b plus 57 and 51 are supplementary angles. Therefore, I can write 9b plus 57 plus 51 is equal to 180 degrees. So all I need to do is just subtract 51 and subtract 57 from both sides. So 180 minus 51 and minus 57. And if you do all that math, what you're going to find is that b is just equal to 72. And then just divide by 9. And if you do 72 divided by 9, that's just 8. So therefore, b is equal to 8. And actually, let me write that up here. So b just equals 8, and we solve for both a and b. And now I need to find what 9b plus 57 is equal to. To do that, I'll just do 180 minus 51, since these are supplementary angles. And that's just equal to 129. So I can rewrite all of this as just 129. So I've solved for a and b, and I found each unknown angle in this problem. If you enjoyed this video, please consider leaving a like and subscribing. Thanks for watching.